Hello everyone, my name is Ravishkar and I work as a customer engineer and data specialist at Google Cloud India. Today we'll talk about why choosing the right database is so important for your applications. But first, let's go through some steps. As per IDC and Gartner forecast, the total worldwide data will swell to 163 zettabyte by 2025. That is the 10 times of the amount of today. Also, by next year, that is 2022, 75% of the databases will be deployed or migrated to a cloud platform. The major key drivers for this proliferation is the adoption of technology trends like mobile devices, which are approximately 3 billion in count and are growing at a 10% per annum scale. Social media platforms, and then there are 20 billion IoT devices are in use in 2020. And cumulatively, they all are generating up to 2.5 million terabytes of data per day. Thus, the big data and the cloud platform becoming the first choice of the organizations to meet the demand of scalability and the ability to ingest humongous volume of data at varying speeds. Also, as per Harvard Business Review, 1% of unstructured and 50% of the structured data is ever used in decision making because the organizations lacks in data management and thus they miss on the new opportunities. And that's why in the 21st century, data is known as the new oil. However, it could be of different variety, structured or unstructured. You need to handle its velocity or volume, and most importantly, data security, both at rest and in transit. To meet these demands, as of June 2021, DB Engines has listed 371 different databases in 15 different database models. But it leads to a set of new challenges, which can be categorized into manageability and choosing the right type of database. So what's tricky with many of these databases is that you need to plan for their scale. Most databases can only scale vertically. Operations, you need to manage hardware breakdown, OS software updates, replication. Keeping replicas in sync is a non-trivial task. And then there will always be a finite replication delay, which you need to account for. Thus, the sharding and replication, it becomes increasingly difficult to have a strongly consistent transactions. Now let's talk about the second challenge, choosing the right type of the database. Firstly, it depends on your industry. Each industry has certain characteristics and end user expectations that may dictate the performance, consistency, or compliance requirements of the data that power those applications. And then there are application demands, like an online application with millions or tens of millions of customers, which want to capture its customer every single action to optimize the product and overall business. Then it must be able to ingest a lot of data with speed and low latency. But what if this data is semi-structured? Or maybe we do not know what all columns are going to be. Putting it into a relational database won't work. So as a solution, a range of NoSQL data stores started to emerge with wide columnar, key value, and the graph types are being the most popular ones. As I mentioned, each industry has its own needs when it comes to engaging customers. For example, gaming industry. They need to support concurrent access by tens of thousands of players and require real-time leaderboard updates. Similarly, in EdTech industry, an application requires a highly scalable storage for high accuracy at targeting, low latency access for dynamic recommendation updates. Then there are domain-driven applications, the ones based on IoTs, which require high-speed ingestion of time series data and highly scalable storage layer for risk analysis. Let's talk about some of these use cases but in more detail. In the gaming industry, the global games can scale unpredictably. And irrespective of scale, they need to deliver the same experience across multiple platforms and countries in real time and low latency. The legacy databases often cannot keep up with that. And that's where you need to adopt a polyglot approach. Now, so that each gaming platform module can be mapped to a right fit database as per the requirement. Like the game's front-end service can use Cloud Firestore to store billions of documents with hierarchical state. and can also hold user data like the player configuration, memberships, friend lists, and presence information. The game servers can connect to regional in-memory database like Cloud Memory Store to access frequently used data in sub-milliseconds. Then you have Cloud Spanner to maintain players' inventory and their match history at planet scale. For backend improvisation, you can log your events to Cloud Bigtable, where developers or support staff can access them for troubleshooting. And at last, the data from the front end and the backend databases can be imported to BigQuery for analytics, leveraging data pipelines. These pipelines can help discover exploits or uncover gameplay mechanics that needs to update before they affect the game's community and drive the player's survey. Similarly, in ad tech industry, you need to maximize the effectiveness of web and mobile ad campaigns. The performance marketers need smart tracking so that they can generate targeted ads to a specific user and have the visibility of its ROI, like an ad bidding platform, which can require up to 800,000 queries per second, or need to capture up to 80 billion page views per day. Thus, you need to require a streaming pipeline with a wide columnar database with the right choice. And hence, you can adopt a Google Cloud Bigtable as it enables a very fast lookups and can be used to store rich user profiles to leverage and build context when serving ads with low latency and high speed. Let's talk about an application in IoT space. Though the consumer segment is the largest user of the connected things, the application tailored to industry verticals are also amplifying the use of connected things like manufacturing field devices, process sensors, and real-time location devices for healthcare. They all need a scalable ingestion and storage layer, which can match the high velocity of IoT data that can be further used for real-time analytics. Following is the reference architecture for the IoT flow and how you can club it with a scalable ingestion layer. The time series data, suppose, which is generating at frequent intervals, can be stored into a cloud bigtable. Whereas the independent sensor data, which can be modeled into a JSON, can be stored into cloud data store. And the data which has already been processed in a relational format can be stored directly in a BigQuery. Then all these databases combined together can be used for real-time analytics. To support all these disparate needs, in Google Cloud, we offer the complete database portfolio, starting with traditional databases such as Oracle, MySQL, SQL Server, Postgres, in order to provide you the ease of migration and compatibility. For your modern applications, our Google-built cloud-native database offerings are available with planet scale and industry-leading availability, like Memory Store, an in-memory key-value database for sub-millisecond response time, Cloud Spanner, one-of-a-kind, auto-scalable, asset-compliant relational database with 5 nines of availability, Cloud Firestore, the serverless document database, Cloud Bigtable, the key value and a wide columnar database for application with low latency requirements. And then BigQuery, a serverless data warehouse platform for all your analytical needs. In addition, we also have a strategic partnership with MongoDB, Neo4j, Redis Labs, Influx Data, and etc. There are a few more partners just to ensure you have the right database platform available for every kind of application you have. But that's not it. We also support you in your journey to the cloud, be it migrate, that is lift and shift of your traditional RDBMS platform on our managed services to mitigate any operational overheads, modernization, to move your database platforms from old guard vendors to our enterprise class open source databases for more optimal ROI and without any vendor lock-ins, or transformation, which is the adoption of best-in-class, planet-scale, low-latency, serverless, Google Cloud native database platforms for optimized customer experiences. And to get started on this journey, we have a migration program that starts with database assessment, which not only recommends the right type of the database, but also helps you in assessing the TCO and reducing the risk during migrations. That's all for today. For more details, log into cloud.google.com and we are there to help you. Thank you.